Hello. So, I start here. Welcome. It's nice to be at the last presentation of the day. So, most courageous people are here. It's a conference about shading and OSL, so it could be difficult for people who absolutely don't know what it is. But I think you will learn something indeed. It's the following of my first conference on this subject about 5 years ago. So many things have changed, include Blender. And I will not talk about EV and I will not talk about 2.8, sorry. So first, the most important news of the day, of the year. It's not Blender 2.8, as you know. It's 3ds Max 2019. Wow, best software in the world, now with open shading language. It's incredible what you can do with it. You can have nodes with your own open shading language shader. You can edit it. Wow. And see it in near real time. If you have a correct renderer. Okay, maybe to remember something for you. What's this function? Yes, 5 years ago, I was here to talk about OSL, just because 5 years ago, Blender was the first to use OSL, to include OSL, to have all the features you have now in 3ds Max. What does it mean? I'm not here to say, oh, 3ds Max is 5 years late. No, absolutely not. It's just that OSL grows and grows every day. And now it's so important that software mainstream and mostly for everyone who have money, like 3ds Max, must have OSL. It's not a choice that they put OSL in 3ds Max. It's because they must have OSL. Because there is so many things. I know that in 2013, yeah, Blender 2.7, yes, I know it's not like 2019, but okay. 2.7, well, this, it's nice. It didn't change a lot, but it was really nice. Actually, the OSL in Blender is better than the OSL in 3ds Max. But I have to check something. Okay. What is important for us to say about this news about OSL is that at first, okay, you are Blender user, you know OSL for 5 years, you maybe who is using it? Yeah. Who? About? No? Nobody? Okay, no, you should learn something. And yes, really, what is different? It was the first, now it's a standard, and it was very difficult to adapt to 3ds Max. You can go to the website of Zap Andersen, and I talk pages and pages about adapting OSL to 3ds Max. 3ds Max is very old. 3ds Max plugin structure is from 1998. So it's very difficult to adapt things like that. So, next. 5 years ago, the OSL world was like that. So I understand why most of you just didn't make big jump to learn OSL, to learn shading language. Just because it was, oh, okay, I have to because I'm using Blender and V-Ray and ALTHOSE. That's all. Now the world is a little bit bigger. Yeah, all the software are using OSL. I think that you recognize most of them, of course. There is the biggest software in industry, in 3D industry, like Renderman, like Arnold, like Clarice in English. Yes, nobody knows it. It's a really cool software. And 3D Lights, V-Ray, what else? 3ds Max, of course, Octane Render, and so on. Even Material X, you know the Material X. Oh, I have a laser. Yeah, Material X. Everybody know about it? No? Material X is a project made by ILM for a little movie called Rogue One. And they need to exchange material between renderers, so they define a new open source standard about material exchange. So now you can make nodes and export nodes from one software to another. Not yet in Blender, okay? But we have OSL. We have the center of all this galaxy. So let's start. Nodes. I know that what's the biggest step of starting shading language is say bye to nodes. In fact, it's not say bye to nodes. Nodes are really cool. Who is using nodes for material here? Yeah. So you know very well nodes. Why should you stop using nodes for using a true shading language? It's not because you like to type and use your keyboard. I think so, but maybe. No, it's just because nodes are really cool. You can do really, really nice things about nodes. And so I made a comparison between nodes and shading language. Yeah. 5 years ago, my presentation was full of spreadsheet, full of graph and so on. And now it's not possible because there is so many renderers using OSL that I can't. So I just make one to compare node and shading language. The most important is, okay, nodes are visual. Shading language is not so visual. You have to read. Everybody know how to read? Yeah, okay. So I think you're okay. Nodes are really cool for doing very, very simple things. You were at the shading conference 1 hour ago, so you saw that it was really cool. Nodes and nodes and nodes. And then zoom out, lot of nodes. So when you do something complex, nodes are not so nice because it starts to be absolutely unreadable. You have just 1,000 nodes on screen and okay, my map is too bright, what I'm doing now. So really, nodes are not readable for biggest shader. Indeed, shading language is really more compact. All the nodes you saw at the previous conference about nice shading, it's about maybe 3 lines of OSL. Okay, you have on one side 20, 30 nodes, on the other side 3 lines. So maybe it's nice to have a look. Indeed, the main difference between nodes and OSL is interoperability. You can use OSL in all those software. Yeah, so what is interesting, it's not the number of software, it's the number of software, of renderer in software. For example, if you use AppleSeed, yeah, I know it's a French renderer, nobody knows it. And so, but it's really, really powerful. If you use AppleSeed, you have AppleSeed for Maya, AppleSeed for Blender, and AppleSeed for 3ds Max. If you made your shader with OSL, it will work, it will run, it will do exactly the same result on Maya, Blender, and 3ds Max. You don't have to redo the job. You do the job once. And so you can say, oh, in my project, I'm not in one thing. I have all those things to play. And all those things on all 3D softwares. And that's the point. You are not just block with your nodes, export, and if you want to re-render in Maya, you have to do the job from scratch. Now, with OSL, you have just to reload your shader. So that's why I really like it. So it was a big project, this conference, big, big, big. So I use 3 shaders for making this conference. Three big shaders. One you already know because you went to all BlenderConf before. It's a jungler. So the jungler was a little renderer inside my renderer, which is rendering this animation. It's just a shader. You put it on a cube and it's doing this, okay? So it's strange. And two others, I'm going to present them. The Jungler, 1986, yes, 22 years old. Someone shows this on a computer and say, wow, we can do animated 3D on your desktop. That was a very big beginning. So if you ask Ton about it, he will talk about hours about that. So what's the difficulties about this shader? It uses incidence. Why? Because if you have to render this scene, you have to know where is the camera and what is the angle of the camera to have the correct scene point of view. So it uses incidence. You can't, if you like nodes, I'm sorry, there is no incidence about nodes. Okay. It is very, very sensitive to scene size. Yes, it's a scene, it's a 3D scene. So if your scene size is about 1 kilometer, it will not work. So it's very sensitive to scene size. It is very sensitive to scene orientation. As you know, Blender is Z up, Maya is Y up, and so on. And RenderMan is Y up with inverted Z. Yes, I know. Minus Z is not Earth, but there. That's only RenderMan that does that. And so it's very, very sensitive. And it's a long shader, about 300 lines. It's not a long shader, 300 lines. Average shader at Pixar in OSL is 2,000 lines. So it's not very long, in fact. Indeed, it takes time. The second is giant LED screen. Giant LED screen, everybody knows this. You take a picture and you make square, and yes, you have a LED screen. This is a little bit more difficult. Why? I have to show you a video. Okay. And yes, this is a video of the giant LED screen with cycles, with Arnold Max, Arnold Maya, RenderMan, of course, Claris, it's easy to recognize, and V-Ray, and I don't have Appleseed here. So what is important is, okay, I have to, yes, no, here, it's on top. What is important is that you see the LED, you see the pixels, there you don't see them. This shader acts like a real LED screen. When you are really far from a LED screen, you don't see the pixels. You see just the picture, and it appears very, very luminous. But when you are close, it's not so luminous, and you see very well the pixel. So this shader has many difficulties. The first one is distance from camera. So the distance from camera, if you are close, you see the pixel. If you are far, you don't see the pixels. But also more difficulties. Use U and V. Okay, it seems not so difficult, but in shading language, using U and V is sometimes difficult. And also, it's just the same shader on all the screen in the scene. So, same shader must have animation and a different picture, according to the object. So, I have just one material for all the screen in the scene. Okay, that's also a good point about open shading language. You can animate it, and you can make it different on each object. It's really nice because there is, in fact, I don't know how much, maybe 200 screens, something like that. So, What it uses also, it uses a cycle, but 10 pictures with slideshow, with blend and so on. A nice slideshow. So you have to load 10 image files. So, okay. It's not, we will see. It's not that easy. The third shader was made for a student project. Is NPAR with 2 lights and a very special way of lighting. You don't light by adding light, but you light by changing color of the map. The difficulty is to have ambient occlusion to make more realistic, and to have also riggable shader, because the lights exist in the scene and you have to take the position of the light, make it an input for your shader, and use this light. You move it in the scene and it moves on the shader. And so you can have really NPAR with a rim light. It's 2 light NPAR. For those who are more interested in this shader, it is the copy of the one used in Kung Fu Panda. No, but just a small copy. Okay, and it works very well, and you have a really nice colorization because you change color. You change color, so when you want green lighting, you just make your map greener or bluer, and so on. It's interesting. It's absolutely not lighting. So, what the difficulty is? There is ambient occlusion, so we need to trace ray across the scene. And also, it could be difficult to have something that is not PBR in a PBR scene, which is not PBR in a PBR scene. So we have to use ray type. What is ray type? This shader is working just for the camera ray. All other lighting ray, shadow rays, and so on, so a usable diffuse object. Okay? So that's also one point. You can make your shading really, really fast by choosing what you do with ray type. And that was those 3 projects. Okay? So let's go. At first, I did this. It was not so easy. I used Claris. I use Maya. I use 3ds Max. I use Blender. I start use Cinema 4D, but okay. And so I use Alembic for making exchange between all those software. Without Alembic, it was not possible. Just Alembic is not transferring materials, so I use OSL for materials. Okay, that's one. Just this. At first, we have to remember what are the goals of OSL. Why Larry Gates, 10 years ago, yes, OSL has 10 years, okay. 10 years ago made OSL. It was because he was working at Sony Pictures, and Sony Pictures doesn't want anything close to RenderMan, but they need a good shading language, so they made their own. And the main goal was to have a clear and simple to use shading language. The shading language is not real-time, it's not OpenGL. It's made for rendering, not fast rendering. So everything is made for getting the most of your renderer. If your renderer has a special kind of subsurface scattering, if the renderer has a special kind of lighting, you can do it with OSL. It's not like OpenGL, or where OpenGL, if your renderer is doing things, OpenGL doesn't know it. So it's really, really specific. And also, it's a good open source product. It's really easy to implement. Software like 3D Light, when they change version, it was easier to implement. It was easier to implement open shading language than to rewrite their own shading language or to implement a RenderMan shading language. So, and so on. If you know the raving rabbits, yes, lapin crétin in French. there's a special renderer called Raving Rabbits renderer. Yes, R. And it's working with OSL also. And just because it's easier to do. And, but as you can see, interoperability between renderer was not in the main goal of OSL. So using it for going from one renderer to another, it's not in the main feature. The only thing common between renderer to renderer in OSL is you, the master programmer of shader, you. And you will know how to do this. It's like C++ when you are coding for Macintosh and for Windows, just near the same. Near. It's near that could be difficult. So like every good game, we have multi-level with a big boss at the end. And so, first level of difficulty. When you are coding in OSL, there is these really nice things called global variables, called inputs also. It's what you can retrieve from your renderer in your shader. There is incidence, there is position, there is normal, there is so on. All information about rendering. As you can see, there is no lighting information. Why? Because OSL is before lighting. OpenGL is after. OpenGL is after lighting. OSL is before lighting. That's why you can't have lighting information. Okay? What it means is that you can make any kind of lighting with OSL. It's pretty simple. You just have P, you just have I, and so on. But, okay, there is nothing really standard. P can be Y up, minus Z, I also, or maybe minus I. And also maybe minus N on a V-Ray, normal and inverted. So when you write your shader using normal, you have to invert your normal. Even time is not the same everywhere. You could say, oh, time, okay, it's time. No, in V-Ray it's ticks. What is ticks? You have 3,000 ticks per second. In Blender, it's frame. You have 1 frame by frame. But if you change frame rate, your shader will not go at the same speed. So, and there is a lot of the little things like that. CI, which is the output, standard output of shader, doesn't exist in Blender, but you have to use it in other renderer. So, even these things, it's not so easy to use. How to find it? That's a problem. How I know when I'm doing my first shader version on Blender because it's fast, because it's real time, I'm doing it and then I import in Arnold. How should I know? I have to write clear code with options like this. For P, I'm not using P equal, my P equal P. I'm using P equal P0, X, Y, Z. Because I could change it in Arnold. And so I can adapt easily to my to the renderer. That's the same for I vector, incidence vector. I have multiply minus 1. I can remove if it's not needed. Okay? The most difficult is UNV. Why it's difficult in UNV, I don't know. I really don't know. Almost all renderers are using minus V instead of V. V is not going from 0 to 1, but from 1 to 0. And there is some special case, like cycles in Blender, where you have to use a get attribute function to have to retrieve UV. Other are really cool, like AppleSeed. I really like AppleSeed because it's just U and V. UNV are just UNV, and you have nothing to do else. Even on RenderMan, it's the most strange RenderMan, because you have to take int log geom why you have this. You may have this to have UNV. Nobody knows why. Indeed, you know how it's the best way to solve a problem in a pipeline, in production pipeline. What is the best way? Don't do it yourself. So instead of coding UNV, you can just put an input in your shader, insert UNV here. And so people will use texture coordinate and plug in it. And that's okay. Okay? So it's an easier way. I spend a lot of time using UNV. You can see, and I don't see you all, but it was not so easy. At the end, for RenderMan, I didn't use it. I just put input UNV. And UNV in RenderMan, it's called SNT. Yes, why? RenderMan is a very, very old software. It's about 28 years old. It's a very old software. That's why there is some very, very strange things inside. Second level, closures. What are closures? Closures are materials in OSL. And closures, it's you can define material in OSL with closures. The common closure as BRDF, Disney material, diffuse, emissions, and so on and so on. Nothing is standard. Indeed, it's not because, I have to click, yes. It's not because they want to be non-standard. The principle of OSL is to take the most of your renderer. And you can't get the most of your renderer if you use the same materials in V-Ray, in Appleseed, or in Cycles. Cycles have really nice and fast volumetric materials. If you want to use them in OSL, you have to use specific materials from Cycles. So that's why closures are very specific. They are made not to make standard materials, they are made to get the most of your renderer. That's why some renderer like Octane or RenderMan say that their materials are so fast, so good, that you don't need to develop your own. So they have no closure. You can't make material in RenderMan or in Creuris with OSL. You just make patterns. I don't like it so much. I love to make my own materials with my own PBR and so on. But it's different. And so, don't spend a lot of time on this if you plan to use multiple renderers. It's better to have your shader in two parts, because OSL is making nodes. So you make one node for the pattern, one node for the material. And so it's easier to go from one renderer to other renderer. Really easier. Because if you want to try to make everything in just one big, it will be, you will have some problem with Octane, with RenderMan, and with Creuris. Claris, who is using Claris here? Isotropic Claris. I love isotropic Claris because time before first pixel, it's a really special unit. Time before first pixel is 0. You have instant feedback in renderer. You move an object, it moves. In the multi-billions polygon scene. That's why I love it. You can have a very big project and continue to work in real time inside. Yeah, I like it for this. But there is no modeler. You have to make your project with Blender, then export to Creuris, and then you can play. That's interesting also. Next time, okay? So closure, you don't have to really worry about them. There is so many of them, there is so many difficulties, there is so many specific things. third problem, what they call advanced function. Advanced function are advanced function. It's communicating with the scene in 3D around. You can communicate with the scene in many ways. Attributes, you can have attributes in your object, like object ID, like object color, or wireframe color, for example, and so on. Object name, also. And you have also get a trace. Trace is shooting array in your scene, so you can make ambient occlusion, for example. You can even make a renderer. If you go on my blog, there is a renderer made with OSL. It works very fine. And you can have also get message and set message. Okay, people who are using cycles don't know them because there is no way to have these two functions in cycles. When you shoot array, the object can send you back a message. And then with get message, you can read what happened. That's really nice to have interactive object. Like, no, I'm not here, go further, and so on. But it's not in cycles. And also there is very, very terrific things like 3D textures. Everybody knows 3D textures? 3D textures are materials, scanned materials. Mostly BRDF, things like that. You have also point clouds. Point clouds, there is no point clouds also in Blender. And you have the set message to communicate. Those three functions are not in Blender, so it's not a problem. We will not talk about that. Indeed, point clouds and 3D texture, with that you can, for example, read a PET scan, if you want to see how you are inside. And or you can also have direct access to OpenVDB. Okay, but not yet. Advanced functions are very, very different from one another to another. You have absolutely no common point. So, for example, for the screen, the giant screen, I need the object ID to have a different screen on each object. And so it was not so easy. This is the Blender version, Appleseed version, Arnold version, the simplest. ID is ID. The Renderman version. And so everything is different. And in V-Ray, you don't have get attributes. You don't have it, so you have to find plan B. What is plan B? If you plan to use advanced function, things how to do not use them. For the giant screen on V-Ray, I use the absolute position in the world for each object. Then I made a random number with this position in the world. So every object are in different positions, so every object has a different screen. It's plan B. You have to think a little bit, how to not use. For the NPR rendering, I need, for the NPR rendering, I need to trace shadow because I have lights and I want shadows. In Renderman, trace is not here. So the Renderman version has no shadows. Okay, I didn't use trace. I use incidence and normal to see what is the difference between the light and us. But I could not have shadows, okay? It's, so you have always to think how to do not use it when you are using multiple renderers. It's not so. Fourth, metadatas. Metadatas are not in cycles. So if you are using cycles, okay, it's something really nice, metadatas. It's a language in language. It's a very small language in OSL, in open shading language, to describe user interface. And you can make a really nice description with this, with a file selector, and so on, and so on. And also you can register node. Instead of having OSL node load your shading, it just appears as a normal node. And so you can make a lot in a production, a lot of useful nodes that you add in your pipeline, and everyone will have those new nodes that you made. For example, you saw at the previous shading presentation that he said about 10 times that he is always making the same nodes. The goal is to make a short script, making those nodes and making the same things. And so you have a new node, you put the image inside, and you have the outside. So you can see here registered node. Node appears as standard node, and it works also in Maya. You can register node in Maya, you can register node in 3ds Max, and you have new node in Maya. It's nice. And also, if you are kind, you can have really nice UI and so really nice user experience who know how to use them. An example, always with the same, AppleSeed. I really like AppleSeed. Here is the cycle version, and I have my 10 pictures there on the giant light screen. And I have to copy-paste the name in each text field. It's a painful task, so I have this node here. I go to check the picture, I copy-paste the path and the name of the picture, and I cut it. Okay, passed here. In AppleSeed, we have really strong metadatas. I just load the file. Okay? So it's really easier. It's more usable, and it works on 3ds Max, Maya, and Blender. So just this node without recompilation. Just put it in AppleSeed and it works. So I really like it. It was a good surprise of this test. It's a big test. And also you can see colors are really small, colors are big. You can animate it also, and so on. And so you can have limits also. In cycles, you don't have limits. Each parameters, which is going from 0 to 1, for example, you can put it at 100. In AppleSeed, you can make limits, and it will not go further than 1. So that's really nice. Next. All those little things that make us crazy. every OSL renderer are different. There is some little things, I stole it for RenderMan. You have the -Z. Z is opposite. So, wow. In V-Ray, your shader file name has to be the same as the name of your shader. You can spend hours because you change the version number and dot in the file. So, what else? So on. There is so many. Oh, in 3D Light, you can make AOVs inside your shaders. Everybody know AOVs? Yeah? And so you can make them inside your shader. That's really nice because you can say, oh, this output to this AOV is inside the shader, and so you can put it on all objects, and that's perfect. And so on. All shading are different. In fact, all software are different. Oh, I don't remember every difference. In metadatas of 3ds Max, you can include pictures. And if you make picture, it will be the picture of your node. It's funny. So on. It's really different. I didn't test Gaffer, which is open source concurrent of Katana. So it's a very big software. And Gaffer has OSL scripting. It's not Python scripting, it's OSL. So it's very strange. I didn't test Fluid Ray. This one be BMRT. And I don't remember all, in fact. Cycle 4D, Material X, soon. And Arnold, of course. Arnold, what is the most perturbation about Arnold is that it's Y up in Maya and Z up in Max. So same shader doesn't work from Maya to Max. Indeed, it works. There is many special case. You can write them in your white book at home. Okay, this shader, this renderer is way up, this, and so on. Once you have them, you can use it, and it works. And it's worked very well. Yes, the jungler is really, really fast. For example, in Claris, you have just, okay, you just click render, and you have the final rendering. Whoa, what happened? Then you can have really, really fast shading also in RenderMan. OSL is as fast as C++ and C# when you are developing for RenderMan. So you can really, really go fast with OSL. And it works very well because you can expand your project. You all know that Blender, you can make a copy of your scene and change your renderer. Everybody try this once. And just ask why I could do that. Now there is a good justification. You can make your character with Blender, with cycles, which is a really nice subsurface scattering, and your volumetric with ALTHOSE. And so your volumetric will be about 10 times faster. And what is nice is you can even use the same shader for the volumetric in ALTHOSE and in cycles. And so it starts to be, so some pipeline example. This one I use for this presentation with Blender, V-Ray for Blender, and RenderMan for Blender, and ALTHOSE for Blender, and cycles. So you change scene, and you just have to have different material. And I even make an automatic selector. It is V-Ray, is it V-Ray, is it ALTHOSE? And it changed. It works very well. But I did it only on a small scene, so I didn't show it. And for people who are using Cinema 4D, who knows Cinema 4D here? Yeah, who is using Cinema 4D? Cinema 4D is really nice for a lot of things, but not all. And you can, if you use Cycles 4D, if you use Cinema 4D, I strongly advise about Cycle. I strongly, yes, use Cycles 4D. It's Cycle for Cinema 4D. It works very well, really, really well. It's faster than Cinema 4D renderer. It's better because it's Cycles, and it's OSL compatible. So you can write your shader in Blender, export, made all the special effects in Cinema 4D, which is really which are really nice in Cinema 4D, all special effects of gravity and things like that, and use the same shader. So it's really cool. And you can even have more strange pipeline like this. This one I use also. From Blender to 3D, to Maya with V-Ray and 3ds Max with V-Ray, then to ALTHOSE, then to Blender again. And it works. That's incredible, but it works. I am the same rendering in 3ds Max, Maya, and Cycles, as you saw in the video. Just the same rendering, and you can change from one software to another. And after you can do anything. This one also I made from Blender to Claris with Alembic directly. It worked really cool. It worked really well. And Claris, we have no closure, so you have to rewrite on a texture pattern only your shader and put it in a standard material of Claris, and it works. Very, very nice. And also use Arnold. It doesn't exist, Arnold. I'm sorry about this one. So we don't have Arnold for Blender yet. But really going from Blender to 3ds Max to Arnold and export the scene to Maya with FBX, and using the same shader in OSL for Arnold. And it works also. And why not go back to Blender and export to Claris for very big scene generation. Claris is really good for very, very big scene generation. The example, the small example, you know, in Blender you have a cube. Yeah, learn with this cube. In Claris there is a 500 billion polygon scene just to learn it. Yeah. So I start to like it. It's very expensive. You can choose it. You can buy it, but it's okay. So it works, really. It's a good way to think about shading language, to say, okay, I'm doing shading language, I like nodes, but why not having a look to shading language? And not only it opens you to the biggest world of shading, but also it opens you to a lot of new renderer. And you know that you don't have to learn this renderer very difficult, very longly, because you can just adapt your shader. And instead of learning the, I think, 200 nodes of Arnold, you can just use OSL and never use the nodes of Arnold. And so it's really faster to learn and to use. For Claris, I didn't have time to learn Claris. I load my scene with Alembic. I go to material. I load my OSL. If my OSL has diffuse and reflection and metallic output, I branch them on the node, render, and it works. So yeah, no need to learn. There is maybe 200, 300 nodes, shading nodes in Claris, so I don't want to learn them. That's why I like it. So if you have any question, I will go to thank you everyone. Thank you, Ton, of course, Brecht, of course. And also, Zap Anderson, we made the OSL adaptation in 3ds Max. It's really impressive, very impressive work, because I thought that it was impossible. Larry Gritz, inventor of OSL, conceptor of OSL. And also François Bonne, who is a programmer, main developer of AppleSeed. And you, thank you to be here. It was not so easy to understand this new world of shading language. I hope you learned something. So if you have any question about anything, I'm checking time. Yeah. Yes.
For what I got from your speech, I assume you can only realize an OSL shader by writing the code. Is there a tool for visual scripting an OSL shader at the moment, or you need to write the code manually?
Hello, it's working. Honestly, I prefer writing the code. I find it faster. Indeed, there is a plugin for Blender, which is called Visual OSL, I think, which make all nodes of OSL and then compile the shader. Okay. And you have the script by making nodes. The main problem
So it's a kind of compilation, you mean?
Yeah, compilation, yeah.
Okay.
Yeah. The main problem with nodes are, of course, to the for instruction, or things like that. When you want to run many times the shader, nodes are linear. They can't go back. With OSL, you can go back. You can make functions. You can make.
You mean you can't make loops? You mean?
Yes, loops and loops, choice, functions, things like that make programming easier and more powerful, mostly.
And one more thing: is it possible to compile a standard Blender or Cycles material to an OSL shader?
When you put cycles in OSL, you have to click on OSL. In fact, all Blender is in OSL at that time. And if you check the sources of, it's open source, so you can, if you check the sources of Blender, you will see all the nodes, absolutely all the nodes of Blender in OSL.
Okay. Including the standard ones, like?
All the standard ones.
Okay.
So it's nice because when you don't know how to make, I don't know, things like edge detection and so on, you just have to check the sources. I use for the bump, I use a very rough bump, like you take the normal and tilt it, and it's really rough and it doesn't work well. So I have a look of the bump node of Blender, and it was really nice with a really nice way with derivative, and so I just copy paste.
And can you do the same thing also for other programs like Maya or ALTHOSE?
For renderer, for open source renderer, yes. For AppleSeed, it's open source, it's not a problem. For RenderMan, that's the difference between free RenderMan and paid RenderMan. It's that if you have the free RenderMan, you don't have the documentation about OSL. If you pay, okay, it's a little bit expensive, in fact, then you have all the documentation. Indeed, with internet, it's near easy to find things about that. So you don't have to pay if you want really to use it. Some others are really not nice, like V-Ray, for example. V-Ray documentation is really short. Octane documentation is really short also. You just have to try and test and see if it works or not. It's not nice. And Claris documentation also, it's just 5 lines. Okay, it should work, yeah. And Arnold documentation is really good. So you can work with it and then use it. That's the main problem, as ever, when you are developing, when you are programming, it's documentation.
Thank you.
Welcome. Other? Yeah, it's open. Yeah. Take the microphone.
Hello. Oh, yeah.
Hello.
Hello. Do you know if there are any future plans in Cycles to extend its OSL capabilities with some of the functions that aren't implemented yet? Do you know if anyone's working on some of those things?
I don't know. I don't know the roadmap of Cycles. I don't know if they include metadatas. I really ask for metadatas every year. I want metadatas. I want to do things I'm doing in other renderer to have nice user interface. So, and I want also OSL GPU on Cycles, but there is not yet OSL GPU in Cycles. There is OSL GPU in Octane. There is OSL GPU in other renderer. I don't remember which one. And no, it's not the priority.
One more question.
Yeah.
I know you mentioned we're not talking about 2.8, but with the Eevee renderer, do you know if there's any plans to make its shaders accessible, if you like, whether it's OSL or some other form?
I don't know. Eevee is really real time, so it should be more open to OpenGL than to Open Shading Language. Open Shading Language is really for renderer, not real time renderer. So you must have time to compile shaders and so on. It can take, if you have 200,000 shaders, it's not from me, it's from Pixar. It's a Pixar information. They tried to make a scene with 200,000 shaders with OSL. You can lose as much as 2 minutes compiling them. So, but it's a very, very big sense. So no real time on Open Shading Language. Maybe there will be an opening to OpenGL. We have to ask, it's this evening or tomorrow? I don't remember. Tomorrow. Yeah.
You should ask after they've had a few drinks.
Yeah. So, anyone? So I was clear or nobody understand anything? Okay, so it's time. It's perfect.